So a radical review, go through several of these together. Remember, when you want to simplify a radical, you want to factor it and look for pairs. So make a factor tree. Any pairs that you find will go outside the radical. So normally I start dividing by 2, but I can't divide 147 by 2. So then I divide by 3, and I'm going to be left with 49. If I divide 49, I can't divide by 3. 5, or, okay, 7. There we go. 7 and 7. And then I'm looking for pairs, because 7 and 7 and 3 are prime numbers. So you can't go any farther. So you stop and look for pairs. When you have a pair of numbers, the pair goes outside. So I have 7 square root, the leftover number stays inside. And then I do the same thing with the x's, or whatever the variable is. I have 4 x's here, and I'm looking for pairs. There's going to be 2 pairs. So that's going to give me 2 x's outside, and there's no leftovers, so there's no x's inside. Okay, that's what you're doing with the radicals. If you've got a number here, like 3 and 4, they happen to be 3 and 4, that's the number of the number in your groups. So the 3 here tells you your groups have to be of size 3. So instead of looking for 2 in each group, you're looking for 3 in each group. And then this 4 over here says the group has to be 4. So you still factor them just like normal, but instead of looking for groups of 2, now you're looking for groups of 3 and 4, where it tells you to. All right, 5 and 6, 7 and 8, similar idea. You want to simplify all of the radicals and then combine any like radicals. So this 72 here, if I divide it by 2, I'm going to be left with 36. And then 36 divides by 2, and I'm left with 18. Divide by 2 again, I've got 9, and then the 9 becomes a pair of 3's. So each of the pairs, I have a pair of 3's and a pair of 2's, goes outside with that negative 3 that was already there. So I have negative 3 times 2 times 3, square root left over 2. Then go to the 18, we have 2 and 9, the 9 becomes a pair of 3's. So the pair of 3 goes outside with the negative 3 that was already there. So we have negative 3 that was there times 3 from the pair, and then the 2 that's left over stays inside. 128, if I divide it by 2, I'm going to have 64. 64 divided by 2 is going to be 32. It's going to be 16. Divided by 2 is 8. Divided by 2 is 4. And then 4 becomes 2 2's. So we got a bunch of 2's here. So there's 1, 2, 3 pairs. And those will go outside with that negative 4 that was there to begin with. So I have negative 4 times 2 times 2 times 2. And inside the square root, we have a leftover 2. And then we multiply the numbers in front and combine the like radicals. So I have negative 3 times 2 times 3. It's going to be negative 6 times 3 is negative 18. Square root 2. And then negative 3 times 3 is negative 9. Square root 2. And then over here I got 2 times 2 times 2 is 8 times negative 4 is going to be negative 32 square root 2. Now since they all have a square root of 2, I can add all the coefficients together. So I have negative 18 plus a negative 9, and then plus a negative 32. And end up with 59. So we have negative 59 square root of 2. Okay, on the next page, these are multiplying. So we need to distribute that radical. When you multiply radicals, the inside multiplies with the inside, the outside multiplies with the outside. So this 10 times 2, they're different, right? 2 is outside, 10 is inside, so they don't multiply. You just kind of put them together. So we have 2 radical 10 plus, when you go to the 10 times radical 10 times radical 2, those are both inside, so they will get multiplied, giving you radical 20. And then what you want to do is try to simplify them if they can. So we have 2 and 10, 2 and 5, a pair of 2's. The 10 is just going to be 2 and 5, so there's no pairs, so that one will not change. But the 20 is So I'm going to rewrite the 2 radical 10. The radical 20 is going to become 2 radical 5. Okay, when you have 11 and 12, you just boiling, if you want to call it that. We're distributing twice. 13 and 14, that's where you simplify the regular numbers with regular numbers and the square roots with square roots. If they don't simplify like this one, then we have to take the square roots and simplify them using the factor trees. If they do simplify like this one over here, then we can just simplify them like a normal fraction. So this one, the 3 on the outside stays 3 because there's nothing underneath it to simplify. But the 15 over 3 inside the square root will simplify. The radicals on number 13, where we have to simplify them individually here, you want to simplify them with factor trees like that. We have a pair of 2's, so that 2 will go outside with the 3. There's a 3 outside there to begin with, so we'd have 3 times 2 square root 3. The leftover 3 is in. And then let's simplify that 75 there. So I'm going to take out a 3 and have 25, and then the 25 is going to become a pair of 5's. So that pair of 5's goes outside, and this is on the bottom. Right, the square root 75 was on the bottom, so it's going to stay on the bottom. So I have a 5 outside, square root 3 on the inside. And then you cancel out whatever can cancel. So I'd have, or multiply what you can multiply, either or both. So I have 6 radical 3 over 5 radical 3, and then these radical 3's can cancel each other out. So this one comes down to just 6 over 5. And then the last group here is where we're doing the solving equations. So you want to get the square root by itself first, and then you can square it. So the square root is now by itself after moving that p. And then I can square both sides. So if I square that, square this is going to become 6p minus 24. Over here, this p minus 4 squared is going to turn into p minus 4 times p minus 4. And then you distribute that, so we have p squared minus 4p minus 4p and plus 16. So I have p squared, the double minus 4p is going to be minus 8p plus 16. And then I need to get it equal to 0 so that I can factor and solve. So I'm going to subtract the 6p and add the 24. And those are going to be gone. So now it's going to be equal to 0. P squared minus 14p and then plus, we've got 40. Then we factor this into 2 binomials. We need to multiply to get 40 and add to get negative 14. So we have p minus 4, p minus 10. So my solutions, or at least my possible solutions, are 4 and 10. So we need to check them to make sure that they both work by plugging them in. So I'm going to go back to the original. Let's erase this to clean up that. So we have negative p, so that's going to be negative. I'm just plugging in 4 first. So we have negative 4 plus square root 6 times 4. Wherever there's a p, I'm putting the 4. And then bring over the equals minus 4. So now I'm just evaluating here. So the 6 times 4 inside is going to be 24 minus 24. It's going to be 0. The square root of 0 is 0. Drop down that minus 4 there. Equals minus 4. 0 plus negative 4 is going to be negative 4. So this one works. So circle the 4. Now I'm going to try the 10. So I have negative 10 going in for p plus 6 times the 10 and then minus 24 equals negative 4. Then multiply the 6 with the 10 to get 60 minus 24 is going to be 36. So the square root of 36 is 6. So I have negative 10 plus 6 and that's going to be -4 as well, so they both work in this case. All right, 15 is similar. It's going to be a lot easier though.